Okay, well, there are two things I want to do today. One, I want to introduce you to the unit circle, kind of show you the patterns, and kind of help you understand why we call it the unit circle. And then after that, if you have any questions over the right triangle CFA we took on Wednesday, you can go ahead and do so. I think the deadline to retake that's going to be next Thursday due to the PSAT. All right, well, let's go ahead and get started. Now, we call it the unit circle because the radius has a length of 1. Now, in the beginning, we're only going to be focused on 16 points around the circle. As we get more familiar with the aspects and concepts of trigonometry, we're going to start looking at angle measures that are not on the right, you haven't seen the unit circle, but for right now, we're only going to focus on these 16. In fact, why don't we go ahead and start? We're going to do this in 3 parts. We're going to look at the degree measures, the radian measures, and then we're going to go ahead and find the coordinates of each of those 16 points. Now, the unit circle, it is a circle with the center placed at the origin of an XY coordinate grid. So this is your x-axis, this is your y-axis here. So one is placed right on top of the other. Okay. Now, we already know that 1 full revolution in degrees is what? 360 degrees. So I'm going to say 0 degrees all the way around to 360 degrees. Well, let's go ahead and fill in what we already know. Half of 360 is what? 180 degrees. Okay, then half of that would be 90 degrees. 3/4 of a rotation, 270 degrees. Okay, well, now we want to go ahead and figure out the angle measures of each of the remaining 12 points. So these clusters of points in each of the 4 quadrants, they are 15 degrees from each other, but the outer points, they're 30 degrees away from the closest axis, whether it happens to be the X or the Y. So I'm going to start off with 30 degrees plus 15. 45 plus 15. 60. Now to get to the axis, I'm going to add 30. So there's my 90. Now to get to this next point, I'm going to add another 30, which would be 120. Okay. Then plus 15, 135. And then plus 15, 150. And then plus 30 gets me to the negative x-axis where I have 180. Okay. And then we just continue this all the way around. What would this next one here be? Okay. 210 plus 15. 225 plus 15, 240, now plus 30, there's my 270, plus another 30, 300, plus 15, 315, and plus 15, 330, and then plus 30 gets me back to the axis where I have 360. Okay, so that's already 1/3 of the unit circle filled in. Okay, so typically nobody has any problems with the degree measures. Are there any questions on that? Okay, the degree measures are these 16 points. All right. Well, the next part, let's go ahead and talk about what's the radian measure at the same locations. All right, so we know we start at 0 radians. 1 full revolution is 2 pi radians. So let's go ahead and fill in what we know. Okay, 180 degrees is equivalent to what? Pi radians. 90 degrees is pi over 2 radians. What about 270 degrees? That's 3 pi over 2. Okay, radians. So we'll go ahead and fill in what we know, because as we go through this, you're going to notice those are going to match up. It kind of confirms that we're on the right track. So here's the thing. There's a lot of different ways to do this. In fact, a lot of people in the past have chosen to memorize the unit circle. Even I don't have it memorized because I don't see the need to do that. I always go ahead and run from the patterns. If it's a multiple of 30, you're going to count by sixths. If it's a multiple of 45, you're going to count by fourths. Okay, so let's start with the 45s. So 45, 90, 135, and all the way around. So I'm going to count 1 pi over 4, 2 pi over 4, 3 pi over 4, and I'm just going to go all the way around for every multiple of 45. So 45 degrees is 1 pi over 4 radians. And if you converted it, you're going to notice that's exactly what you get. Now, the next multiple would be 2 pi over 4, but what's 2/4? Yeah, 1/2. There's the 1/2 pi that we have already got. So I've got 1 pi over 4, 2 pi over 4. What would 135 be? 3 pi over 4. And then when you get around here to 180, 4 pi over 4, there's your pi. Okay, so keep counting for me. What would come next? 5 pi over 4, located at 225. 5 pi over 4. And now 270, well, that would be 6 pi over 4. But you'll notice, what is 6/4? It's the 3/2 we already have there. Okay. Well, then what would 315 be? 7 pi over 4. And then we get all the way back around to the x-axis where we have 8 pi over 4, which is my 2 pi. Okay, if it's a multiple of 45, you'll count by fourths. And some of these are both going to have factors of 30 and 45, and that's fine. Okay, it's just another way to make sure you're getting the right values. Any questions on that? Okay, well, if it's a multiple of 30, I said we were going to count by what? By sixths. So I'm going to start here at 30 degrees, so that's 1 pi over 6. And then I'm going to do the same thing we did with the fourths. 2 pi over 6, 3 pi over 6, all the way around for every multiple of 30. So this one right here, 60, is 2 pi over 6, so that's actually pi over what? Pi over 3. And then the next one would be 3 pi over 6. But what's 3/6? 1/2. Okay? So help me as we go around. The next multiple is 120. What are we up to? 4 pi over 6. But what's 4/6? 2 pi over 3. Okay. So the next one would be 150, which is, what are we up to? See, we counted 1, 2, 3, 4. Now we're up to 5 pi over 6. And then 180 would be the next multiple of 30. So 6 pi over 6, that's where we get the pi. Okay, what's next? 7 pi over 6, which would be at 210. Then 240 would be 8 pi over 6. Well, what's 8/6? Okay, so 4 pi over 3, or 4/3 pi. And then we get around to 9 pi over 6. 270, the next multiple. But what's 9/6? 3/2. Okay, so again, it's matching up. So what's 300? There you go. So 10 pi over 6 becomes 5 pi over 3. 330? 11 pi over 6. And finally, we get back around to the x-axis where we have 12 pi over 6, which is also 2 pi. Okay, so there we go. Now we are 2/3 done with the unit circle. There's a lot of information on it. Okay, any questions? Okay, anybody having a hard time not seeing where I'm getting these from? Okay. Now, the last part, I want to take each of these 16 coordinates and I want to know what the location is. So I actually want the x comma y point. Well, remember, why do we call it the unit circle? What's the length of the radius? The radius is just 1 unit. Now, I do want to go ahead and say that as we go through our trig unit, we're going to be looking at circles of different sizes. They're going to have different lengths for the radius. All the information is still going to be accurate. Okay, now it's going to change slightly because of the length of the radius, but all the information is going to remain the same. Okay, so I'll show you what we mean as soon as we get to an example. But what would this point be right here? If the length of the radius is 1, and remember, this circle is on top of the XY coordinate grid. What's that point right there? Yeah, that would just be 1, 0. So 1, 0. So what would this point here at pi over 2 or 90 degrees be? That would be 0, 1. What about 180 degrees pi radians? -1, 0. And finish up, 270, 3 pi over 2. 0, -1. Okay. Now those are the 4 easiest points to find because they're on the axes. Everybody's okay with that? But now, in order to find the coordinates at, say, for example, 30, 45, and 60, we're going to use triangles to do so. So I already came in previously. I went ahead and drew a bunch of right triangles based on the points. So there are going to be 12 total because there are 12 remaining points. So here's what's really nice about this. Every one of these 12, they're either a 45, 45, 90, or it's a 30, 60, 90 triangle. These are going to be the side lengths that you're going to find each and every time. So let's start with the 45, 45, 90. Okay, so let's say I have a right triangle here that's 45 degrees, 45 degrees. Now, the only thing we know for certain is that the radius, which turns out to be the hypotenuse for each of these triangles, has a length of 1, right? So let's see, where do I get the leg lengths of the square root of 2 over 2 that we have here? Well, in terms of x, what's the relationship between the three sides of this kind of triangle? It's x, x, and in order to find the hypotenuse, you'd take a leg and multiply it by the square root of 2, right? Well, both 1 and the square root of 2 represent the same side length, correct? So I'm going to set them equal to each other. I'm going to say 1 equals x square root of 2. How would I solve for x? Oh, they wouldn't square it because, see, that's actually working backwards from getting x. We just want to isolate it. What's that? Okay. What's that, Jordan? There you go. Just go ahead and divide through by the square root of 2. Because those are going to cancel. So I've got x equals 1 over the square root of 2. But we don't want to leave a radical in the denominator. So what do? We're going to rationalize this. So I'm going to multiply it by our version of 1 that we've mentioned many times. So that's where I get the square root of 2 over 2. So that's why on the unit circle, if you come across a right triangle that's a 45, 45, 90, the legs will always have lengths of square root of 2 over 2. Okay. Any questions on that? All right, well, let's see why a 30, 60, 90 looks the way it does on a unit circle. Okay. So again, I got a right triangle. Okay. Again, not to scale, that's okay. Let's say this is my 30, this one ends up being my 60. So all I know for sure is that the radius of the circle, which is the hypotenuse, has a length of 1. Okay. Well, in terms of x, what's the relationship between the three sides here? Okay, so the shortest side across from 30, remember that was x. How do I use x to find the longer leg? X times the square root of 3. And then what do I do to x to find the hypotenuse? 2x. Okay. Is everybody okay with that? Well, it's like we did a moment ago. Okay, the only side length I know is the hypotenuse, so I'm going to set that length equal to the 2x that I have there. So if 1 equals 2x, divide through, x equals the 1/2. Okay. So if I want to go ahead and find the longer leg, I'm going to take that x value and multiply it by the square root of 3. So 1/2 times the square root of 3, that's where we get square root of 3 over 2. Okay, so every 30, 60, 90 triangle that shows up on the unit circle, that's why we have legs of those lengths. Now those legs, they're going to help me figure out what the coordinates of each of those points on the circle are going to be. Okay, so any questions about that? Okay, so let's actually see how this works. Let's go back to our unit circle here. Let's say I actually want to know the coordinate right here at 30 degrees. So I'm going to go ahead and get this ready. Okay, there's my XY coordinate. So I'm going to draw the radius. I'm going to connect the origin here, 0, 0, to that point that I want. Now, in order to create the right triangle, you're going to connect that point perpendicular to the x-axis. It's always, always going to be to the x-axis. What does perpendicular mean? Okay, intersects at a right angle. So see, that's where your right triangle is coming from. Now, how do we always rotate in a plane here? If I want to go ahead and rotate counterclockwise, we start from what position? Standard position. So if I started here and rotated, wouldn't that make this 30 degrees? So what would this one right here be? 60. Now we know we're dealing with the unit circle, so that hypotenuse, the radius, has to be 1. Well, think about this triangle we saw just a moment ago. What's always across from 30? 1/2. What's across from 60? There you go. So across from 30, I'm going to go ahead and say 1/2. Across from 60, I'm going to say square root of 3 over 2. So I'm going to use the side lengths of the triangle to help me figure out that coordinate. Because if you want to plot a point in an XY coordinate plane, well, you start at the origin, and what do? What do you do first? Left or right or up or down? Left or right, depending on your X value, if it's positive or negative. And then you move up or down depending on the Y. So if I want to go from the origin here to this point at 30 degrees on the circle, well, I'm going to have to move how far right? Square root of 3 over 2, and then how far up? 1/2. So the coordinate on the circle right there should be the square root of 3 over 2, 1/2. And what's nice about this, even though there are 12 triangles, there's only 2 types. It's either a 45-45-90 or it's a 30-60-90, and guaranteed it's going to have these side lengths. It's going to be the same triangles over and over and over again. Okay, so let's try the next one. Let me go ahead and erase this here. All right, so let's say I want to know the coordinate right here at 45 degrees, pi over 4 radians. I'm going to connect the origin to that point. From that point, I'm always going to drop it straight down, perpendicular to the x-axis. Always, always, always to the x-axis. Okay. Well, what do you think this base angle is right here? Yeah, that's 45 degrees. So that means this other one's got to be 45. Now, we're on the unit circle, so I know the radius, that hypotenuse is 1. So now it's a 45-45-90. What should the legs be on this triangle? They're both square root of 2 over 2. Okay, so I know this length is square root of 2 over 2. I know this height is square root of 2 over 2. So how would I move from the origin to get to that point on the circle? Yeah, I'd move square root of 2 over 2 units right, and then square root of 2 over 2 units up. Just like I'm plotting a point. I'd start at the origin, I'd move to the right, and then I'd move up to my destination. Is anybody having a hard time with this? Is anybody not seeing where I'm getting these values from? Okay, let's try another one. Let's try the coordinate at 60 degrees. Now you're going to notice something. I'm going to go ahead and draw the hypotenuse here. Okay, or right now it's the radius. I'm going to connect that point perpendicular to the x-axis, just like that. Now, what's this base angle right here? It's 60. That means this one's got to be 30, but it doesn't matter how the triangle looks. It's the same 30, 60, 90 triangle we've been looking at. That hypotenuse has a length of 1. What's across from 30? 1/2. What's across from 60? Square root of 3 over 2. Okay, so using those legs of the triangle, well, what's the coordinate at 60 degrees? You'd go 1/2 square root of 3 over 2. Everybody's seeing how I'm doing this. Okay. Now, as we push forward, you're going to start to see why certain vocabulary words, why certain concepts were covered. Let's go ahead and do one more of these. Now, we already know the coordinate at 90 degrees, pi over 2 radians. We know that's 0, 1. Let's say I want to find the coordinate at 2 pi over 3 radians, 120 degrees. Same thing. I'm going to draw the radius to that point. And then what am I going to do to make the triangle? Always, always connect it to the x-axis. That's where it's going to be perpendicular. Okay. Well, here's the thing. We started in standard position. I rotated over 120 degrees. What's this reference angle right there? 60. If I rotated 120, it would take an additional 60 degrees to get to the x-axis. Remember, between the terminal side and the closest x-axis. So if that's 60, that means this one's what? 30. Again, it's the same triangle. The radius is 1, so that means the hypotenuse is 1. Across from 30 is 1/2. Across from 60 is square root of 3 over 2. But I can't help but feel I'm missing something. What quadrant are we in? We're in the second quadrant where x is negative. So I would go ahead and put a negative on that horizontal movement. Now, we're not saying that that's a negative 1/2 length long. The negative simply tells you the direction you're going to have to move. Okay? So what would the coordinate of that point be right here on the circle at 120? Negative 1/2 square root of 3 over 2. In the second quadrant, x is negative, y is positive. Okay. Now you'll notice, could I go ahead and continue this, doing a triangle for every single one of them? Okay, we can, but there are better ways to do this. Let me go ahead and erase this. In fact, do you notice some symmetry here? The unit circle is symmetric with what? Where could I fold and get the same graph? The x and the y axes. So let's start with the y axis. What if I were to fold along the y axis? Would these 3 points here correspond to the other 3 over here? Yeah. In fact, take a look. 60, this point would match up perfectly with the point at 120 degrees. How did that original coordinate change to get in the second quadrant? What became negative? The x value. So instead of creating triangles, well, why don't I just go ahead and reflect it over? What would 45 degrees correspond with? 135. So Connor, what would that be? There you go. So it's just this point reflected over. If you're reflecting across the y-axis, well, the x values are going to change sign. 30 would correspond to 150. So what happens to square root of 3 over 2, 1/2? Negative square root of 3 over 2, 1/2. There you go. Okay, it's just all about the patterns. Is there anybody who's not seeing how I did that? Now, let's say I want the 3 ordered pairs for 210, 225, and 240. Okay, well, I could just take the graph and I can reflect it across the x-axis. These points are going to correspond as well. In fact, 150 would correspond to what? It would correspond to 210. But now, what quadrant are we in? Okay, 3. What do we know about x and y in the third quadrant? They're both negative. Okay, so if at 150 degrees I have negative square root of 3 over 2, 1/2, presumption, what would that coordinate be at 210?
Wait, are we at 150?
Yeah, we're at 150, and we're going to reflect it over here.
Positive 3.
Ooh.
Is it on the...
Remember, what quadrant are we in?
Oh,
The third, where they're both.
I mean, square root of 3 over 2.
There you go. So I know that 135 would correspond to what? 225 if I reflected over the x-axis. Clarissa, what would be the coordinate at 225 degrees? There you go. And we'll finish up. 120 would correspond to 240 if I reflected over the x-axis. And Jordan, what would you say that is? I want to reflect over the x-axis. So I'm taking the point that was at 120 degrees, helping me with this one.
Negative 1/2 square root of 3.
There you go. Okay. And then now for this last quadrant here, you could go ahead and reflect these 3 across the y-axis. I would probably just go ahead and take the points in quadrant 1 and reflect them across the x-axis again. Okay. The point at 30 degrees, if I were to reflect across the x-axis, what would he correspond to? 330. So we're in the fourth quadrant. What do we know about coordinates there? X is positive, y is negative. Okay, so Jordan D. What would happen to square root of 3 over 2, 1/2 if I reflected it into the fourth quadrant? There you go. Okay. All right. Sorry? What would happen if I reflected square root of 2 over 2, square root of 2 over 2 over here? What would that give me for 315 degrees? Okay. And our last one, 300 degrees. Jake, what would that give me? There you go. And that is our unit circle. This is what we're going to be using for a very long time. In fact, our happy minutes are going to be based off this. Okay, I know. Now, I would encourage you to practice this. Like I said, I don't think it's necessary to memorize this. I don't even have it memorized. But you should be able to go ahead and draw a complete unit circle and fill it in inside of 5 minutes. Now, that's about right now. As we move forward, that time should shrink. Because on quizzes, on tests, I will not be providing a unit circle. So if you want one, you'll have to quickly use it or just kind of focus on the triangles, whichever you think is going to be best for you. Okay. Yes, ma'am. This is not on the exam. No. This is not on the exam. We have not had time to practice this yet. In fact, now that we know what the unit circle is, the next lesson is learning how to evaluate trig functions using this. So we don't have to use a calculator. Okay. All right. So now let me go ahead and show you a shortcut. Okay, to getting all of this. You don't have to use triangles, nothing. Okay, so let's say you're starting from scratch. You don't have anything. Okay, I'm going to focus all my attention on quadrant 1 because it's really the easiest quadrant to deal with. We know this is 0 degrees. Remember, this was 30, 45, 60, 90. Okay, if it was a multiple of 30, we counted by what? We counted by sixths, so this is pi over 6. 30 would be, or should be 60 would be pi over 3. And then 90, we know that's pi over 2. If it's a multiple of 45, we count by fourths. So here's pi over 4. Now we know these 2 points here, this one's going to be 1, 0. This one would be 0, 1. It's very easy. But I want you to go ahead and take a look at the 3 ordered pairs here in quadrant 1. If you have those, you could simply just reflect to any quadrant you want. Okay, well, do you notice anything about every single one of these x's and y's? They're all divided by what? Every single one of them is divided by 2. So I'm going to divide by 2, divide by 2, divide by 2, divide by 2. If you go ahead and start on the inside track here for the x's, start at the very top, just count 1, 2, 3, and then count up 1, 2, 3. Now take the square root of your numerators. But what's the square root of 1? 1, so you just have to take, okay, in seconds you can get the entire unit circle. Second period was a little more impressed with that. Oh, how fast can I do it? I could probably do it in about a minute and a half. I'm not going to show off for people. Also, I've been pleased. What? No, I'm good. Any questions about the unit circle? Okay. The one thing to remember, though, as we move forward, I will never ask you to do something that I could not do. So if I give you a certain time limit, that means I can't do it. I mean, shoot, right now, 5 minutes, I could probably walk downstairs, get myself a drink, come back up here, still do the unit circle, and have time left over. T. See, that's why I don't want to do it. I'm not going to show off. I've had a little more practice at this. Okay, questions?
So what kind of tea is it?
Well, if I go out, I'm going to drink unsweet tea, but I like to bring gallons of sweet tea up here. I don't know how many ounces that
How
is.
fast do you walk?
How fast do I walk? Depends on what I'm walking towards.
Do this.
If it's something I want to do, quickly. If it's something I don't want to do,
So where does the unit
take my time. Okay. Well, we've reached the boring part of the lesson, okay, because we're talking about Mr. West. Let's move on. The only other thing I want to do, were there any questions on that CFA from the other day? Okay, because there are several times on the test Monday where you'll either have to find just a missing side length or a missing angle. Do we want to talk about either of those? Actually, I did go over the data. I've never seen this before. You know, what I took away after looking at the data on Wednesday was that there's a group of students across all the classes, not in one class, that are having difficulty with this concept. Because these are the percentages of people who missed. This is every pre-cal student I have. Okay, the percentage who missed number 1, 14.8%. Number 2, 13.9%. Number 3, 12%. Number 4, 14.8%. So that was like straight across the board almost. So that's why I decided I wanted to go ahead and do this today. So are there any questions on this? Hey, it was in the grade book on Wednesday. Mm-hmm. Sure. Okay. So nobody wanted to talk about a missing side length or even how to find a missing angle. Do we remember how to do that? We did that a week ago. A missing angle? Because that's something you'll have to do on the test. In fact, let's go ahead and use one of the triangles that we were just looking at. Let's say I have one of the 45 right triangles from the unit circle. Remember, the hypotenuse is 1. What were the legs of this triangle? Square root of 2 over 2, right? Okay. So what if I did this? What if I only gave you 2 sides, erased these angles here, and said this was theta? And I said, go ahead and find the missing angle theta. Well, what are the 2 sides? What are they to theta? They are the opposite and the hypotenuse. And what's the third side? The adjacent. We don't need that here. I just wanted to go ahead and bring that up. And maybe this will help some folks out if you're one of those people who did miss these questions. Maybe it's not a bad idea in the beginning to label the sides just to kind of help you make a connection with the trig function. So what trig function uses opposite and hypotenuse? Sine. So I could say sine of theta equals the opposite square root of 2 over 2 over the hypotenuse 1. But that's just the sine of theta is equal to the square root of 2 over 2. Now, is that the only trig function I could have used for this? Okay, what's its reciprocal? Cosecant. I could have said cosecant of theta equals 2 over the square root of 2. Okay, I just would have flipped it. Okay. Now, here's the thing. Let's just go ahead and run with this right here. Now, you evaluate a trig function at an angle measure, right? And your answer is the side ratio of the lengths of a right triangle. Well, how would I work backwards and find theta? That's when we take the, starts with I. That's when we take the inverse. So I evaluate sine inverse using the ratio, and that should give me my angle measure. And in fact, here we know it's what? Because I just drew the triangle. 45 degrees. And that's one thing you're going to want to make sure of. You're going to want to make sure that your calculator is in degrees on Monday. So I'll go ahead and make a little, announcement about that at the beginning. Chris Thompson? Oh yeah, you'll have to. Because eventually, when we actually get into a lesson on inverses, I'm going to have you do that by hand. So you'll have a protractor. You'll actually be measuring out the lengths and finding the angles. It's more fun than it sounds. Okay. Well, that is your choice. I hope you won't do it.
Are there going to be a large number of these questions or just a small?
I think I've got maybe 3 or 4 on there, similar to this. Some of them are word problems too, where you just talking about creating a right triangle. Yeah. All right. I believe there are 9 questions total is what I put on there. 9 questions total, with the last one being the angular and linear velocity. Okay. Anything else?
On the test, are the points like split up in questions, or is it just?
Yeah, I haven't even. I'm working on the key right now. I'm almost done, and then I'll go ahead and decide what the point spread's going to be. Okay. Anything else? All right. So it doesn't happen often, but we actually finished up early today. Looks like we still got a good 12, 13 minutes. Okay. So good.